over here. So these are the things we're going to do inside here. The first thing is to approve the function to take the input amount from us. The input amount we defined in the epoch config, which is somewhere here. Input amount. Yes, it's going to take this amount and swap it from us. So going back here, after approving is in worth, it's going to tell us once it's approved, then we will log this. The next thing is to call the function itself. The function takes the input amount, just as we have it here, amounting. The token we are passing in, wrapped Ethereum. The token we want to get out is USDC. We are swapping on this pool and the price feed, right? So after that, we can delete these comments. Okay, everything should be okay now. I think, all right, so let's get the balance of USDC after we do the swap. So after we do the swap, we are going to check the amount of USDC we have. Before the swap over here, let's get the USDC before the swap so that we are sure that there is difference before and after balance. All right, okay. As before, I'll just come to the make file and define the command to perform this swap. But I need to do something over here. Since we are not our swap, the function takes the amount in from us. It doesn't take it from the contract. So there's no need for us to fund the contract. So here I'm just going to comment out this line. Yes, so we are not, just for this test, I will uncomment it after. So just for us to do this swap script. Now, so I'm going to bring up my terminal. Let me just write this and clear it up so that it makes it easier for us to follow. Restart the blockchain. All right, it's up and running. So the first thing, as before, is to deploy. After deploying, okay, we've been able to deploy. The next thing is we are going to now get worth in our wallet. We are not funding the contract. So I'm just going to copy this command. Just still on Arbitrum, make get worth in Arbitrum. Let's see what it does. So you can see what it does now. Got worth in my wallet. That's all. It's not funding the contract. You don't need to do it too. So let's perform the swap now. I'm going to run make swap on Uniswap v3 on Arbitrum. All right. So let's see. Hopefully everything goes well. All right. It has gone well. Let's see. Worth current balance. So calling Chainlink to get the current price. It's in USDC. I told you USDC has 10 raised to power 6 decimals. That's why. So this is 4,635, and you have 6 digits afterwards. All right. Then before we do the swap, because we didn't fund we didn't have any USDC on the contract, so it's 0. Then we approved wrapped Ethereum for the swap. Then the swap take place, and final USDC balance on crosschain collar is 2.99 USDC. So yeah, this works well. Finally, here there's a final script we need to write. This will help us to get the token balance of our crosschain collar. So after this, we are going to the testnet. We are going to bridge from base to Arbitrum, then also swap. So at the end of that, in order to be sure that all our transaction was successful, we need to get the worth balance of the cross-chain collar. So this is the function that will return the worth balance. We also need to get USDC balance of the cross-chain collar after we do the bridging and also sending the swap message. All right, so please pause the video and get this script down. It's nothing different from what you have done. We are just calling balance off on this iWef, this this interface. All right, now as before, we need to write the commands we are going to need. Now we are going to live testnet. So since we are going on a live testnet, we are going to be using our actual wallet. So, and it's best practice that you encrypt your private key. So I need you to quickly watch this video and encrypt your private key. By the way, if you want to integrate blockchain solutions into your business, or you have an idea of a blockchain application and you want me to write that for you, or you just want me to audit your code and take a look at your code base for you, please check the description to this video, book a call directly with me, and I'll take it from there. If you're a blockchain developer and you still include your private key in the .env file, relying on the fact that you would not, by mistake, push your .env file into the GitHub, you need to sit down and watch this video. My name is Abolaji and I've been developing in the space for more than 3.5 years now. The trend of hackers and scammers reaching out to blockchain developers like you and I on various platforms, especially LinkedIn, is rising. Their purpose is to ensure that we download their code into our PC. The code will be running in the background and it will search for our private key, then send it to them. In fact, recently, a blockchain developer lost about $500,000 worth of crypto because of this. So keeping your private key in plain text is not safe anymore. In fact, what is expected is for you to encrypt your private key. And once it's encrypted, you can also be using it while you're developing. In the next few minutes, I'm going to show you how to encrypt your private key using Foundry. So I need you to like this video, share and subscribe. Share because of your other developers and help us get this word out there so that we all stay safe. I'm going to show you the list of private keys I have encrypted in Foundry. So I'm going to run cast wallet list and I have my dev key and my production key already encrypted. All right. So to encrypt another one, let me clear this. We are going to run this command, which is cast wallet. If you check Foundry documentation, you see this cast wallet imports, and the name I'm giving the new private key I want to encrypt is YouTube key, and it ends with -i. So with this, it's going to prompt me for the private key of the new account. So for this example, I'm going to open a terminal. I'm going to run Anvil, and Anvil will give me 10 private keys. All right. So the first one, I'm going to use it for this illustration. So let's say I want to encrypt the private key of the first dummy wallet there. So I'm going to paste the private key here. Then it asks me for password. I'm going to put a password there now. All right. And I've encrypted it. YouTube key has been, and this is the wallet address. All right. So if I want to get, so I can run cast wallet list again to be sure that it's there. You can see YouTube key is there now. So we've successfully encrypted it. You can see it's simple. Then the next thing is, how do I use it? Okay, so I have a contract here that I can use for that purpose. Yeah, this is my deploy script. So I'm going to deploy this on this local network I've started up, and I'm going to use that private key we have just encrypted. This is the command we are going to run. Let me just copy it here. All right. So the command is for script, where the deploy script is located, then the RPC URL, which is the local host, the account we are using, this is the private key, the wallet address of the account, which is the first wallet here. That's the one we use, the private key. So this is deploy it. You can see it's going and it has deployed. So don't forget to like this video, share with all your blockchain developers, friends, and subscribe for more tips like this. See you on the next one. Now, so for us to be able to test on the testnet, we'll need it to pay for gas fees. We need some Ethereum to pay for gas fees. And the way we can get that is to go to faucets. We have to search for Ethereum faucets. So just search for base Sepolia it faucets on Google. The first one for Alchemy should be okay. So once you click it, it takes you to this page. Then you can paste your wallet's address here and send ETH to yourself. It's testnet, it's not real, so it's not free money. All right, so this is for base Sepolia. If you need for other network too, like Arbitrum Sepolia, you can change the testnet, the network here, and also put your address, and you get Ethereum sent to you. And because I already have, I don't need some ether. I already have, so I can pay for gas fees. Now that you have your testnet tokens, so let's write the commands that will help us to deploy to live testnet. So I'm just going to come here and write the first command to deploy. Okay, I'm going to shift this down before I explain the command. So let me just this is testnet fork command. So all the commands down here are for testnet fork. All right, here we are deploying to base Sepolia with this command. Everything is as before. Now we are adding this RPC URL argument. Then we put our JSON RPC, the account, the private key that we've encrypted, the wallet address we are using to deploy. Then this broadcast means that it's deploying. This verify keyword means that our contract will be verified on the testnet. So the code will be live there. I was having problem when I was preparing for this. I was having problem with verification of my contract. Hopefully everything has been resolved now. All right. So yeah, this dash VV means that it should log what it's doing per time. So if there is error, it will log it down for us in detail. So this here, that's for the base. For Arbitrum Sepolia, the same thing, just different JSON RPC, our wallet address, broadcast, and we also verify. Now, this parameter here, Basecamp API key, we need to get this API key from Basecamp, the explorer for Base. This will allow us to verify our contracts programmatically instead of going and doing it manually. So you need to get the API key. For Arbiscan too, that's for the Arbitrum side, you need to also get the API key. So that will allow us to verify automatically while we are deploying. You just need to create accounts on the explorers on Arbiscan and on Basecamp. Then you'll be able to get the API key. The remaining commands we are going to need, I'm going to write them down here. All right. So the first, after deployment, we'll need to fund our contracts. As before, don't forget that the testnet tokens we got is Ethereum. So we need to convert the Ethereum to wrapped Ethereum, right? So this will help us to do that. Wrapped Ethereum, then we'll fund the contracts. That's what this will do. Get weights and fund contracts. The same thing for Arbitrum. We may not need that on the, we may not actually run this because this we'll be bridging from base to Arbitrum. All right. Then we can now bridge token from base to Arbitrum. So here again, you will see we are calling that contract we have written, and the script rather we've written, that's transfer from base to other chains once you call handler. So please feel free, pause and copy down this command. All right. The same thing for token balance. So after everything, we need to get the token balance to be sure that it was successful. And that reminds me, here we need to uncomment this line so that we can fund our contract. Before we deploy on testnet, I'm going to add this line of code. This will help us to store our cross-chain caller address on Arbitrum. We are going to store it on our contract on Base. To leave the link to how you can get this Base Scan API key in the description of this video. Once you get it, you just come to your .env file and you're going to include the keys here. So you just put the value here and that's it. So now we can now come here and deploy our contract on the live testnet. Let's start with base Sepolia. So I've copied the command. I'm going to run make deploy. Hopefully everything goes well. It's running and it's asking for my password. It's password to my encrypted private key, and it has deployed. It's trying to verify, but hopefully, let's see. It's still waiting in the queue for verification. It has deployed here, but it's trying to verify. So I'm going to this is the contract address. While we wait for it to deploy and to verify, let's see. It seems it was able to verify. Yes, that's good. Our contract has been verified. So I'm going to come here now. I'm going to paste the contract address. We are on base Sepolia scan. Yeah, this is our contract. You can see created like 1 minute ago. So you can see the code here because it has been verified. All right. So we are doing well. You can see our read functions that we can call, write functions on the contract, the ones we can call. All right, that's good. We are going to have to do the same thing for Arbiscan API key. So in the .env file, once you get the API key for Arbiscan 2, you put it here, and after that we can now deploy as before. So I'm going to come here. Let me just clear my terminal. I'm going to run make deploy Arbitrum on Sepolia. While it's still going on, okay, it's asking for my password so fast. So while it's still ongoing, I forgot to get this contract address. Yes, I've copied the contract address here. I'm going to come to my helper config here. Don't forget I was using random values here. So here I'm going to put the correct, since we have deployed our contract address, so the correct contract address for our cross-chain caller address on base Sepolia. All right, this is also, it's been deployed to and it has also verified. So I'm going to copy the address as before. That's great. So I'm going to come to Arbitrum Sepolia Arbitrum scan here on the Explorer. I'm going to search for the contract address. Yeah, you can see we've just deployed it. It's here now. You can see our code. It was verified. All right, so everything is okay. Again, I'm going to copy the contract address and put the correct contract address in our config file. All right, that's good. Everything is working well so far. Before we bridge the token, let me show you my wallet This is, we are on base Sepolia now. You can see I have about 0.267 ETH, and I have wrapped Ethereum. This was what I got when I was trying to prepare for this video. So it's 0.0859. All right. So let me switch to Arbitrum over here. Arbitrum should be somewhere here. Yeah, Arbitrum Sepolia is here. All right. Now Arbitrum Sepolia, I have 0.48 ETH here. Wrapped Ethereum 0.0246. All right. So that will help us to know when we are successful, because over here we are transferring quite small amount. The amount we are transferring is quite small. So yeah. All right. So yeah, we got an error, and it's because I'm still using 100 worth amount for the worth amount. So I'm supposed to use a small number because I don't have as much as that in it. So I'm just going to come here. Here's the worth amount. Instead of 100, I'll just use the input amount. Should be okay now. All right. So I'm going to clear this, run it again. And it's asking for my password. So good sign so far. Good. That's great. So it says, yeah, we've been able to get wrapped Ethereum. Now we can bridge. So I'm going to come here now, and I'm going to call this command bridge. Let me clear here, make. I'm going to run this. Hopefully everything goes well. It's going. It's asking for password. Over here, we have success. Everything seems to go well. But the only way we'll know if everything has gone well is to come here and check our contracts. So let me start with Arbitrum, the destination contracts. Over here, for us, we can check here. Let's check the token transfers. And this, you can see what has just happened 3 seconds ago. This was not there before. This is fuel relay. This was the amount we got. Don't forget that we sent 0.001, and we were going to get 96% of it, which makes it 0.00096. So this was what we got. And when the swap also took place, we got 2.87 USDC coin on our contract. So if I come here now, don't forget that we didn't make any transfer into this contract. So if I come here now, let me click this transaction hash and see what happened. Okay, in the transaction hash, this was what happened. This is our multicolor contract. This is the multicolor contract, and this is our contracts. Let me be sure of that. Yes, let me be sure of our contract address. Okay, 773. All right. So if I click the transaction hash now, I can see the details. So this is our contract is here. So some token was transferred to our contract, which is this. Then it's called the swap on our contract. And it swapped the token to USDC for us. Now, the funny thing on swapping or on testnet is that on the live net, it's meant to take the wrapped Ethereum from you and give you USDC. But when you're on testnet, because you're testing, it doesn't take anything from you. It just gives you the USDC. So you end up with both USDC and wrapped Ethereum. So everything has gone well now. So a good way to also test, let me refresh this, and it will tell us now we have 2 tokens on our contract on Arbitrum. We have USDC and the wrapped Ethereum we transfer. So you can see that's good. So another way to test is to come back here and run this command. That's the purpose of this command we wrote. Token balances on the Arbitrum. So I'm going to run make this, and it's still going. Oh, sorry about that. Yeah. So you can see the 0.00096 and the USDC that we have 2.87. So at this point, please don't forget to like, subscribe, and share this video. It's been quite. I'm going to leave the link to the verified contracts on Base Sepolia and also on Arbitrum Sepolia, so that if you're having challenges at any point, you can look at the code there. All right.